Okay, folks, we're going to try to derive a formula for cosine of A minus B. Now, what does that mean, cosine of A minus B? That means cosine of angle A minus angle B. Normally, we just have cosine of some angle, pi over 6, or 60 degrees, or 120 degrees. This, we're going to try to have cosine of two angles related to one another by subtraction. So let's take a look at the picture we have here. I have drawn here a point cosine B sine B. This point is cosine B sine B. And just imagine we have a unit circle where this length is 1, and therefore this angle is going to be angle B. And we also have cosine A sine A over here at this point, and this side length also is going to have a length of 1 because these are like unit circle values, right? The points at the end of these lines. And therefore, this angle here is angle A. Therefore, the angle between these two lines is angle A minus B, or has a measurement of angles A minus B, right? So that angle from one line to the other is A minus B. So with that, let's take a look at a particular line. I want to look at this line. I'm going to try to put it as a dashed line. I'm going to start here. I'm going to go to here. I want to take a look at this line. All right, so this is line AB. This is line AB. Type in AB. That's line AB. Okay. Now, I wonder if we can figure out the length of that line. Well, I can actually think of two ways to think of the length of that line. One way I can think of would be law of cosines. So law of cosines. In other words, we have a triangle. I'm looking at a triangle, and it's got side length 1, another side length 1. It has an angle in between it of A minus B, and it has this side length over here called AB. I'm going to move that a little closer so we like this is side length AB. So using law of cosines, we would say that AB squared, meaning the side length AB, quantity squared, would equal the other two sides, 1 squared plus 1 squared, minus 2 times 1 times the cosine of A minus B. That's using law of cosines, which you learned in a prior chapter. We could simplify this to AB squared equals, let's see, 1 squared plus 1 squared, that's supposed to be, is 2, minus 2 times 1 is just 2 times cosine of A minus B. All right, so that's using law of cosines. Now, another way we could look at this is kind of like the distance formula, or the hypotenuse of a triangle. I'm going to draw a triangle. Let me see if I can use a different color here. Color like, let's use this pink color. I'm going to draw a triangle from here to, oh, it's not like what I'm doing, from here to here, and from here, another one from here to here. All right, so what I've drawn is a right triangle with a height here and a base across the bottom and a right triangle. And therefore, using Pythagorean theorem, we can get AB again. So this way, or distance formula, however you want to think of it, AB squared would equal the height squared is going to be sine B minus sine A, right? Because these sine values are the y values of these values. So we have to subtract sine A from sine B. So sine B, oops, that looks weird. Sine B minus sine A squared, right? AB, this is A squared, B squared, C squared, squared, uh, plus the length across the bottom here. This is cosine B, and this is cosine A. So the difference between those two locations is going to be cosine B minus cosine A. So kind of the same thing as the sine B part. Cosine B minus cosine A squared. All right. So that statement equals AB squared, and the statement that we had from law of cosines also equals AB squared. So they're the same thing. So we're going to be able to use like a system of equation to say that eventually that this, we can say it now, is equal to this. Okay. But let's take a look at simplifying this Pythagorean theorem one, because I bet there's some trig identities in there that we know already. So let's multiply these two statements out. So in multiplying them out, we're going to wind up with sine B squared minus 2 sine A sine B uh, plus sine A squared. Oh, I should be putting the squared over here. I should not. Here, I'm going to erase this. This is bad nomenclature over here. That's not the way it should look. It should look this way. There we go. So there's the first statement multiplied out. I'm going to run out of room clearly, so I'm going to do the second statement right below it. Plus cosine squared B minus 2 cosine A cosine B plus cosine squared A. All right, so there's the second one multiplied out. So this is this one multiplied out, and this first row is this one multiplied out. Now, if we add those together, cosine squared B and sine squared B, these two equal 1. And cosine squared A and cosine sine squared A, these two also equal 1. Now, these two in the middle don't add together. So 1 plus 1 is 2. So that's going to equal 2 minus 2 sine A sine B minus 2 cosine A cosine B. All right, all I'm doing is adding these two things together, but I've used a trig identity here and here. All right, both of these statements equal 1. So now we have, and this is all equal to AB squared. This is all equal to AB squared. Okay, so this equals AB squared, and this other statement equals AB squared also. Now we can look at these two statements that must equal each other because they both equal AB squared. I think that we can subtract 2 from both sides, basically eliminating this and this, right? Subtract 2 from both sides. Then we could actually divide by -2 because all of these terms have -2 in them. And our result is going to be cosine A minus B equals sine of A sine of B plus, because we're actually factoring out a -2. We're actually factoring out a -2 plus cosine A cosine B, right? If we divide the whole statement by -2, we wind up with plus signs everywhere. So that is a difference formula. Now, from this, we'll get a few others, but that's the first step. Cosine of A minus B is this identity. Cosine of A minus B is equal to sine A times sine B plus cosine A times cosine B. That's going to go on your colored sheets with all your trig identities. That's not one you have to have memorized, but it is one that we're definitely going to use.